So thank you very much for letting us presenting you the climate station. We are developing with my colleagues from the GRC listed here and colleagues from ICPAC to support us to develop this climate station. It's a very relevant presentation. If you saw the previous presentation, is really relevant. The task of the GRC with the ERIC and EUMETSAT task. Instead, if you look at the global framework of climate services proposed by WMO, you can see here the different interaction you may have. And we are in the context of the CLIMSA program. We have the list of the action done by the GRC to support RCCs like ICPAC. And you can see the pivotal role of the climate station to make the connection in between the data providers, typically EUMETSAT, but also all the services from Copernicus, WMO tools and others, and the RCCs like ICPAC. And this climate station allows the RCCs to get all the information they need to download and to tailor to national weather services and to different institutes and different end users they have in there at regional and local scale. And you have some activities going from, I mean, more top down, like the tailored product and services and quality control and fitness for purpose to fit very well the data to the needs. But we need also this two-way interaction, co-construction of the climate station with information coming back from the RCCs to the data providers and to us to have some requirements consolidation and to better fit with the needs and to develop, to co-construct really together this climate station. So what is the objective of the climate station? The main objective is to transform the data sets, all the data sets you may have in different from different data providers into information. So reduce this burden of the data sets and to increase the time for analysis and interpretation. So when you have the climate station, the climate service, you in the operational context, if you co-construct correctly the data, the climate service, you need a very high quality and tailored tailored product into your catalog. And this is only done with this co-construction, with this dialogue with RCCs and end users. At the GRC, have also a long experience of doing such kind of product, and we have also a lot of we develop also at the European level. We developed a lot of data set that can be relevant for the users. I can mention very quickly the Copernicus services, the different services you can find for maritime, for global land, for emergency management services, and for climate as well. You have the Sentinel images, the Sentinel satellites, and we have also a long expertise in developing such kind of climate station of this kind of soft installed in Africa. I can mention here Puma, AMSD, MESA, and the ongoing GMS in Africa, if you know. The main requirements is to receive, I mean, it's a single entry point for different data sets coming from different data providers, satellites, model, ground observations. And we need some automatic chains computations inside the climate station to generate some derived products. And we want also an approach which is multi-scale, multi-sensor, and multi-modals. First, because we are looking at a large scale. So basically, a good product in one region is not necessarily good for another. But also, we know that for many variables, we have a lot of uncertainties associated with it. And having this kind of approach, we can assess this kind of variability and we can assess this kind of uncertainty. So what is the conceptual design? We start first by the data acquisition. So basically you have the different data providers, EUMETSAT, you have the American, the European services, the Copernicus services, and so on. And you have also local stations. And all this data will come into the climate station, and then you start to process the data by using automatic chains of processing using GDAL, Python, R and different other soft that will be included into the climate station. And at the end, you have this kind of tool, the data analysis. Either you can export these data sets to be used in other front-end software, like Eric presented previously for the East Africa Hazard Watch, or you can use it directly in the climate station with the data analysis tools that I will show you just after. Just to mention that we have two different kind of station. You have the physical one, which is basically the setup of an the setup of computers that download the data locally and generate the different processes, and you generate your data analysis. But we will have also very soon the online version with the full access of all the data sets available, and but it needs of course a good internet access, and that will be released by the end of this year, and that can be used by everyone. So what data are we going to put inside? So basically, after some initial surveys and bilateral discussions with RCCs, attending COF, and some feedbacks from ICPAC, that is very proactive for that. We have a series of data sets we have identified as very important. So we have three categories. The first one is the monitoring part, basically for observations, climatology. So basically, it's you can use it, the reanalysis, ERA 5, MERA, for example. You have also some local observations that can be imported through the ClimSoft, the WMO ClimSoft toolbox. ClimSoft will be also included into the climate station. And you have also access to the satellite images from EUMETSAT presented previously by Mariette. We have also some inside the station. The station will be able to calculate some derived climate indices, the anomalies, tercile, extreme values. That is very useful for the COF. We saw this morning. It's very useful and very relevant for different services and different thematic. And we have also included into the station, we will have also some advanced products. For example, the state of the ocean, so for dipole of the ocean, and GRC in-house products, namely, for example, the fires, the monitoring of fires, the flood extent, the droughts monitoring, the vegetation states, the forest, fishery, and energy, and so on. The second series of dataset will be the seamless weather forecasts. So the purpose is not to look at the nowcasting and the forced for the weather for the few days, but more for weeks and months. So it's from midterm to seasonal forecast with a multimodal approach to better assess the uncertainties. And we will have also some accurate derived products from extended ensemble seasonal 5, the seasonal forecast from ECMWF, and some also products derived from Copernicus EMS for flood forecasting, low flows, extreme precipitation anomalies, droughts, and so on. And finally, the last part, which is still under discussion, is to include some climate projection coming from CEMIP 6, but that will be just static data set of climate projection. We will have also some additional toolbox like Impact, which is a portable GIS to analyze the satellite images. And for this is an example of the monthly cloud-free composite of Sentinel-2 done by, realized by using this Impact toolbox. Impact will be included, is already included in some RCCs associated with the climate station to communicate the data and to import the data the toolbox needs. And you can then use the toolbox to visualize the deforestation or the state of the forests. And another product that will be soft that will be included into the climate station is the Jupyter Notebook. It's very useful to handle big data sets, or also to compute very specific tasks, but also it's a very good way to test and develop your own procedure chains if you want to develop your own. So basically, this is the list of script. And if you enter, you see that it's quite interactive with some information about the data you manipulate. And then you can generate very high resolution images, like here from Sentinel images. And this product, so Jupyter Notebook, is already included into the climate station. And finally, to assess the data intercomparison and the fitness for purpose. So basically, to measure the uncertainty of the variable you assess, We have also included another toolbox that has been developed at the GRC level. It's a way to compare the information coming from different sources. This is an example for the albedo, for example, over a certain grid point, and we have a series of data sets of tools, sorry, included into this toolbox to better assess what is the characteristic of the data you're using, and if it's maybe better to change to another, or at least to assess the bias in between the data you're using. Just to let you know about the status of the development of the climate station at ICPAC, I think Anthony to send me the slides. It's just so the station is already installed at ICPAC level. This is the status of the so basically you have some already download data. They have already download data sets with different category: oceanography, rainfall, vegetation, fire, and inland water, and so on. And with this, you can manipulate. This is the analysis done at ICPAC level. So basically, you see the different functionalities of the data analysis into the local climate station. So you have a map. You can navigate into. You can zoom in, zoom out. You can add layers, vector layers for the boundaries, for the region, and so on. And you can also plot different products. And you can also plot some time series, for example, or others, scatter plots or whatever. And it's very interactive and it's fully customizable. So I don't want to go into details because I don't have time today, but it's the people that start to use it knows about that. And this is just an entire comparison of the rainfall from 2021 to the other years. And another example of the scatter plots you can use into the analysis. And everything is saved into a workspace that can be reused operationally. So it's very convenient at the operational level. So to conclude, we have co-construct this free software for climate station in collaboration with RCCs, and we think again ICPAC to be very productive, and it's the most advanced RCC for to support us to develop this climate station. And we collected some needs for the variables, the derived and tailored products, functionalities they need. The development includes some toolbox, a lot of toolbox coming from WMO or the GSE or well-known like Jupyter Notebook to reinforce the quality and the reliability of the CSIS. And a prototype version is distributed in some RCCs, ICPAC, for example. And in the future, we want to provide all the data sets considered as important by the RCCs for the monitoring and the forecasting aspects. The online version, as I mentioned previously, will be available by the end of this year to be used by everyone as soon as you have a good internet access. And of course, it's important to maintain the trainings and workshops to explain better the usage of the data sets and the different functionalities we provide into the climate station. So if you have any question, I'm free, I'm available. Thank you for your attention.